Assalamualaikum and good day to everybody. So this is part 3 of EXERGY. So in this video I'm going to explain the second law of efficiency. Second law efficiency. Second law efficiency. Efficiency system performance. Let's say we have a two-heat engine, one with the heat source of 600 Kelvin and another one is with the heat source of 1000 Kelvin. System A and System B, and both have the same heat sink, which is 300 Kelvin. In normal case, we use thermal efficiency to calculate the efficiency of the system, which is from the first law of thermodynamics that look into the quantity of energy. And this calculation or this equation has no reference to the best possible performance of the system, and the performance is misleading. So why it is misleading? Since if you look at the heat source, system A has 600 Kelvin and system B has 1000 Kelvin, but both of it has a thermal efficiency of 30% if you calculate from this equation, which is W net out divided by Q in. Although system B has a high heat source, but the thermal efficiency is the same as system A. So and now we look into the second, which is the reversible thermal efficiency, which is based from the second law of thermodynamics that look into the quality of energy. And this calculation has the reference to the best possible performance, and from this equation we can calculate the reversible thermal efficiency. And system A has the 50% of reversible thermal efficiency, and system B has 70% of reversible thermal efficiency. So from these two systems, which one has higher performance? So to know the higher performance of both of these systems, system A, system B, we need to calculate by using the second law efficiency. So this is the calculation equation used to calculate the second law of efficiency, which is the ratio between the thermal efficiency and the reversible thermal efficiency. And this calculation is for heat engine system. So from this equation, we know that system A has 0.6% of second law efficiency, and system B has 0.43% of second law of efficiency. And from these two systems, we know that system A is the best, since the heat source is 300 Kelvin and it deliver the same work net out with the system with the heat source of 1000 Kelvin. It is like the ratio of the heat output power by the heat source. Second law efficiency, an analogy. So I already explained how to calculate the second law efficiency, and for further understanding, let's say we have a person with a muscular body and another person, a normal guy, B person. So A can carry maximum 70 kg. So this is his maximum performance. Whereas B, he can only carry 50 kg. This is his maximum performance or maximum load that he can carry. However, for the current performance, person A carry 30 kg and person B also carry 30 kg. So from these two guys, which one is better, or which one has higher performance? So for this case, B has higher performance. Why? Because it operates close to his maximum capability. This is what is the second law of efficiency. Other second law efficiency expressions. Second law efficiency. So we know in engineering device we have a lot of system: heat engine, turbine system, pump system, and many other system, refrigeration, all sort of thing. So for this case, we can divide it into 4 category. One is the heat engine. Heat engine, this is one example of heat engine. It's combustion engine. And the second law of efficiency is shown as in this formula or equation, which is the thermal efficiency divided by the reversible thermal efficiency. So another category is the work producing device, such as turbine. So this is the second law of efficiency, which is the useful work divided by the reversible work. Another thing is the work consuming device, such as pump. And the second law of efficiency is equal to reversible work divided by useful work. Please keep in mind there is differences between the work producing device and also work consuming device. Another thing is the cyclic device, such as our refrigerator and heat pump. So the second law of efficiency is equal to the coefficient of performance divided by coefficient of performance reverse. Second law efficiency, differences between turbine and pump. So as you can see in the previous slide, I already show we have 4 category, which is heat engine, work producing device, and work consuming device, and another one is the cyclic device. So here I'm going to show you the difference between the work producing device and also work consuming device. Let's look first at the work producing device, which is turbine. So this is the same equation as I showed in the previous slide. So the thermal efficiency, not thermal efficiency, the second law of efficiency is equal to useful work divided by reversible work. And also for work consuming device, which is pump, the second law of efficiency is equal to reversible work divided by the useful work. How do we get this? Because as you can see, it's almost opposite. So let's say we have a turbine, simplified turbine, in, out, and then work out. So the best performance of this is work out maximum. That is the best performance that we need and that we looking for. That's what the system is designed. However, what is the maximum potential? The maximum potential should equal to the reversible work. And this is the maximum potential of the system. However, in the actual system or actual condition, we have a losses. So the useful work should be lower than the reversible work. Now let's look at the work consuming device, pump. This is the in and out, and then work in. So what is the best performance? So for pump, we need the lowest energy as the best performance, lowest work in as the best performance. And the max potential is reversible work should equal to the work in with the minimum value of the work in. However, in actual condition, since we have losses, so the useful work will be larger than the reversible work. So this is the differences between these two systems, although it look almost similar. But since the work that we want for work producing device is the work output, whereas for work consuming device, the work that we want is the work input with the minimum value. So there is a differences in the calculation of the second law efficiency. Okay, so general definition of second law efficiency. So second law efficiency is equal to exergy recovered divided by exergy expended. Exergy expended is the exergy that being used. Exergy recovered is the reversible exergy. And you also can calculate by using 1 minus exergy destroyed divided by exergy expended. Exergy expended is the maximum exergy that can be used. And exergy destroyed is the exergy that cannot be reversible. So we look into the all 4 system heat engine. Exergy recovered is equal to W net out, and exergy expended is the QH minus the QL. and here QL is 0 and it equal to QH, and the irreversibility I is the exergy destroyed. Now we look into the refrigerator. XQL is the exergy recovered, and X W net in equal to W net in, work net in. Irreversibility I. So now we look into the heat pump. XQH W net in is equal to W net in. Exergy destroy is the irreversibility, and electric heater XQ is the exergy recovered, and X equal to work electric in is the exergy expended, and the exergy destroy is the irreversibility I. Please keep this is in mind. So which one is the exergy expended? For heat engine, the exergy expended is the QH from the heat source, whereas for refrigerator, the exergy expended is the work net in. And for heat pump, same with the refrigerator, the exergy expended is the work net in. But as you can see, between refrigerator and heat pump, the exergy recovered is XQL for refrigerator and XQH for heat pump. So there is slight difference here. And for electric heater, the exergy expended is equal to electric energy or electric work input, and the exergy recovered is the QXQ or heat in the indoor system. So this is the equation, and WE equal to. So this is the end of part 3 for chapter 1. Okay, thank you for your attention, and hopefully you find it useful for your study.